Now let's speak about acceleration. Acceleration means the rate of change of velocity. Rate often means per time. Acceleration is change of velocity per time. How much of velocity changed in a certain time. And the unit of acceleration is meters per second, because change in velocity is measured in meters per second, and then that is divided by time. So meters per second divided by second. Another way of saying meters per second divided by seconds is meters per second. Another way of saying that is meters per second squared. Meter dot second to the -2. Be very careful not to get mixed up between meters per second and meters per second squared. They do not mean the same thing. Meters per second refers to velocity or change in velocity. Meters per second squared refers to acceleration. So what's the acceleration of this stone? Let's take the first interval. The velocity changes 10 meters per second within that interval, and that interval lasts a second long. So the acceleration is 10 meters per second change in 1 second. 10 meters per second 10 meters per second squared. During the second interval, the change is again 10 meters per second. And again, that change happens in 1 second. So again, the acceleration is 10 meters per second squared. Pause the movie while you answer the other questions. Can you see that the acceleration is always 10 meters per second squared in this particular case? The reason for that is because here the stone is accelerating under the influence of gravity without any other influences, without air resistance. We say it's in free fall. In free fall, things accelerate to the earth at approximately 10 meters per second squared. In each of the intervals shown here, the change in velocity is 10 meters per second and the interval's time duration is 1 second. So that's why in each case we've got 10 meters per second divided by 1 second, 10 meters per second squared. But now let's define our interval as the entire motion shown here, from time 0 up till time 5 seconds. What is the change of velocity per time for that big interval? We've already seen the change in velocity for that interval is 50 meters per second change. Starts off at 0 meters per second, ends at 50 meters per second. That's a 50 meter per second change. In how much time? How much time did it take for the velocity to change that much? This interval lasts 5 seconds. T final, 5 seconds, minus T initial, 0 second. So what's the acceleration for this interval? Acceleration delta V divided by delta T. Change in velocity for this interval is 50 meters per second. The time duration of this interval, 5 seconds. 50 meters per second per 5 seconds is 10 meters per second 10 meters per second squared. There's a change of 10 meters per second in each second. Now let's use the interval time equals 3 seconds up till time equals 5 seconds. How much does the velocity change during that interval? Final velocity 50 meters per second, initial velocity 30 meters per second. 50 minus 30 is 20. The velocity changes 20 meters per second during that interval. How long does that interval last? The interval lasts 2 seconds. Final time is 5 seconds, initial time 3 seconds. 5 minus 3, 2. 2 seconds duration for that interval. So what's the acceleration for this interval? Acceleration equals delta V divided by delta T. The change in velocity for that interval is 20 meters per second and the interval lasts 2 seconds. 20 meters per second per 2 seconds is the same as 10 meters per second per 1 second, 10 meters per second squared. So notice that no matter how we choose our interval, you will still find that the acceleration is 10 meters per second squared for this particular motion.